Hi guys, welcome back to Math with James. So today we have this problem. We have a function fx is equal to x cubed minus 3 times x squared plus 1. And the domain for this function is from -1/2 to 4. And the question asks us to find the maximum and minimum value of the function. So today I'm going to use this computer algebra system to do the graph. So I have already inserted this function over here, x cubed minus 3 times x squared plus 1. And the graph is over here. So we can pretty much zoom in and we can see between -1/2 and 4, that's the domain of the function. We might have the minimum over here, right? And we might have the maximum somewhere in the top. That's just approximately what we have from the graph. If we want to get that mathematically, we have to use calculus in this case. So I'm gonna get a screenshot of this graph over here, and then I'm gonna explain that a little bit on the blackboard. Yeah, let's just put it over here, get it smaller. I'm gonna introduce you guys two theorems. The first theorem is Fermat's theorem. So Fermat's theorem says if a function has a local maximum or minimum at a number c, and also if the derivative of c exists, then the derivative of this point is 0, and the derivative of this point is also 0. So you want to use the graph how to show what the derivative is equal to 0 at this point. That means the tangent line over this point touches this curve actually is parallel to the x-axis. That's what it means. But that's one more thing that you need to understand. Sometimes the function might not be differentiable, which means don't have a derivative over here. That gives us the second concept, a critical number. What is a critical number? So a critical number of a function f is a number c in the domain of the function such that either the derivative of fc is equal to 0 or the derivative of c does not exist. For example, if you have a graph like this, put a sharp over here, and it's a critical point, but the derivative doesn't exist. So we're going to use a method called the closed interval method. Closed interval method. Step 1, you have to find the value of f at the critical numbers. And the second step, find the value of the function fx at the endpoints of the interval. The next step is you need to compare these values. Which one is the biggest one and which one is the smallest one? The largest value is the maximum and the smallest value is the minimum. So by using these tools, it's going to be super easy for us to find the maximum and minimum value of this function.
Okay, let's go.
All right, guys, I'll see you guys next time. Take care.